Welcome to Learning with UNP. In this session of Python for Data Science, we are going to understand about set basics. That includes understanding about creating a set, length of a set, characteristics of set constructor, type of set, and finally understanding about set membership. Let's begin with understanding about what is a set. Set in Python is a collection of unique elements that are unordered and unindexed. They are useful for membership testing, removing duplicates, and performing mathematical operations like unions and intersections. Set is an unordered collection and they do not support indexing, slicing, or other sequence like behaviors. Now, let's look at creating a set. A set in Python can be created using curly braces containing comma-separated elements. This syntax is similar to that of dictionary creation, but unlike dictionaries, set do not contain key-value pairs. Alternatively, the set function can be used to create a set from any iterable such as a list or a string. Here is the syntax of it. This line creates a set named mySet containing the elements 1, 2, and 3. Let's look at the pseudocode representation of it. Step 1. Define a variable mySet means initialize a variable named mySet. Step 2. Assign a set of unique elements enclosed in curly braces to mySet means assign a set containing unique elements enclosed in curly braces to the variable mySet. Here are two examples demonstrating how set in Python can contain diverse elements and are displayed without any specific order. In the first example, we initialize a set called mySet with the elements 1, 2, and 3. Using curly braces to denote a set, we assign these values to mySet. Upon printing mySet, it displays 1 to 3 indicating the set contents. In the second example, we create another set named mySet which includes elements of different data types. The integer 100, string welcome, and floating point number 3.333. Similar to the first example, we use curly braces to define the set. Upon printing mySet, it displays the output. Let's execute this and check. As discussed, here are the outputs. Now, let us look at finding the length of a set. The number of elements in a set can be determined using the length function. By passing the set as an argument to length function, you can quickly and efficiently count the unique elements within the set. This provides a quick and efficient way to count the unique elements contained in the set. Here is the syntax of it. This line assigns the number of elements in the set mySet to the variable length. Let's look at the pseudocode representation of it. Step 1. Initialize a set variable mySet means initialize a set variable named mySet. Step 2. Use the length function to determine the number of elements in the set means utilize the length function to calculate the number of elements contained within the set mySet. Step 3. Assign the result to a variable length means assign the result of the length function to a variable named length. This example demonstrates how to determine the number of distinct elements in the set. This example initializes a set named mySet with various elements. Using the length function, it computes the count of unique elements in mySet and stores it in the variable length. Finally, the length is printed using the print statement. Let's execute this and check. As discussed, here is the output. Over here, let's look at the characteristics of set. First comes unordered. Set is an unordered collection, meaning the elements within them do not follow a specific sequence. Consequently, the order in which elements appear when printed or iterated over might differ from the insertion order. Set is designed for efficient membership testing and eliminating duplicates rather than maintaining order. Second comes immutable elements. Elements in a set must be immutable, meaning they cannot be changed after being added to the set. This allows set to maintain integrity and ensure reliable behavior during membership testing and operations. Third comes duplicates not allowed. Set do not allow duplicate elements. When an attempt is made to add a duplicate, it is simply ignored. This feature is useful for ensuring that all elements in a set are unique, which can simplify data handling and prevent redundancy. Here are examples demonstrating characteristics of set. In the first example, a set named mySet is initialized with elements 3, 1, and 2. Despite the ordering in the initialization, when printed, the set displays elements in a different order due to the inherent unordered nature of set. In the second example, we initialize a set called mySet, including the elements 1, 2, and 3. We print the myset using this line. An attempt to modify an element using myset of 2 equals to 98 leads to a type error because set do not support item assignment. This demonstrates the immutability of set elements. In the third example, a set named myset is initialized with a combination of elements like integer 1 and 2, the string hello, and the tuple 3, 4. When printed, myset displays all these elements, showcasing that set can contain a mix of different data types including integers, strings, and tuples. In the fourth example, myset is initialized with elements 1 to 1 to 3. However, when attempting to create a set with a list 1 to 3, Python raises a type error, as shown here, because set cannot contain mutable elements like list. Set require elements to be immutable for consistent and reliable operations such as membership testing and efficient storage. In the fifth example, my set is initialized with the elements 1, 2, 1 to 3, same as previous example. Similarly, a type error is raised again because set cannot directly contain other set as elements. Set can only contain elements that are immutable, ensuring the integrity and predictable behavior of set operations. The same is explained here. In the sixth example, we initialize a set called mySet with the elements 1, 2, 3, 4, and 5, where each element is having a duplicate value of it, and we print it using the print statement. But the output displays only unique values as set do not allow duplicate values. Let's execute all these examples and check. As discussed, here are the outputs of all these examples. Let's now look at the set constructor. The set constructor is a built-in Python function that creates a set. It can take an iterable as an argument and convert it into a set, automatically removing any duplicate elements. This function is handy for quickly generating set from other data structures like list or tuple, ensuring unique elements within the resulting set. Here is the syntax of it. This line utilizes the set constructor in Python to create a set named myset from the iterable provided. It automatically removes any duplicate elements from the iterable, ensuring that myset contains only unique elements. This construction provides a convenient way to convert other data structures such as list or tuple into set. Let's look at the pseudocode representation of it. Step 1. Define a variable myset means define a variable named myset. Step 2. Assign a set created using the set constructor with an iterable as an argument to myset means utilize the set constructor passing an iterable as an argument to create a set. Assign the resulting set to the variable myset. Here are three examples demonstrating the set constructor. In the first example, a list called myList is initialized with various elements including integers, string, and a float. Then the set constructor is applied to myList creating a set named myset. When printed, myset displays only the unique elements from myList, removing any duplicates automatically. In the second example, a tuple called myTuple is initialized with consecutive integers. By using the set constructor on myTuple, a set named myset is created. Printing myset reveals that it contains only the unique elements from myTuple, demonstrating the removal of duplicate values. In the third example, a dictionary called myDict is initialized with key value pairs representing various attributes. When the set constructor is applied to myDict, Python considers only the keys of the dictionary. Thus, myset comprises unique keys from myDict. Printing myset displays the unique keys, highlighting how the set constructor works with dictionaries. Let's execute all these three examples and check. As discussed, here are the outputs. Now, let's move on to understanding about type of a set. The type of a set can be determined using the type function. By passing the set as an argument to type function, you can quickly identify whether a variable is a set or not. This function is useful for verifying the data type of an object, aiding in debugging and ensuring code correctness. Here is the syntax of it. This line assigns the type of the variable myset to the variable setType. Let's look at the pseudocode representation of it. Step 1. Initialize a set variable myset means initialize a set variable named myset. Step 2. Use the type function to determine the type of myset means utilize the type function to identify the type of the variable myset, which indicates whether it's a set or another data type. Step 3. Assign the result to a variable setType means assign the result obtained from the type function to a variable named setType. This example demonstrates how to use the type function to determine the data type of a set in Python. We initialize a set variable named myset with the elements 1, 2, and 3. Using the type function, we determine the type of myset. The result representing the data type of my set is assigned to the variable set type. Finally, we print the value using print statement. Let's execute this and check. As discussed, here is the output. Lastly, let's look at the set membership. Set membership refers to checking whether a specific element exists within a set. This can be done using the in and not in keywords, which returns true if the element is found in the set and false otherwise. Set membership testing is highly efficient due to the underlying implementation of set, which uses hash tables. This efficiency makes set particularly useful for scenarios where fast lookups and ensuring unique elements are important. Here is the syntax of it. This expression returns true if element is found in my set and false otherwise. Conversely, this expression returns true if element is not found in my set and false otherwise. Let's look at the pseudocode representation of it. Step 1. Initialize a set variable myset means initialize a set variable named myset. Step 2. Determine the element to check means determine the element you want to check for existence within the set. Step 3. Use the in keyword to check if the element exists in the set means use the in keyword followed by the element to check if it exists in the set myset. Step 4. Perform actions based on the result means based on the result perform actions accordingly. Finally, this example demonstrates how to use the in and not in keywords for membership testing in set. In this example, a set named mySet is initialized with a mix of integers, string, and floating point. Through the use of in and not in keywords, membership testing is performed to check for the existence or absence of specific elements within the set. The expressions true in my set and HII not in my set returns true outcomes, indicating the presence of 2 and the absence of HII in the set, respectively. Conversely, 4 in my set and 3 not in my set returns false, indicating the absence of 4 and the presence of 3 in my set. Let's execute this and check. As discussed, here is the output. This is all about today's lecture. See you in the next lecture. Thank you.